Hello, Lato students. Welcome to 2B. We're going to talk a little bit more about parallel and perpendicular equations today and how to write those equations given different pieces. So the first thing that we are looking at today is a couple little definitions that are going to help us in a few minutes. They're not going to help us with example 1 and 2, but they're going to be really important to us when we get to example 3. So if you have not defined this word yet, a bisector, it's popped up a couple times in our notes so far, but a bisector means, well, let's break this down. Bi means two, like bicycle. Bi is two. Sector is to separate something. So bisector means to separate it into two parts. So a bisector is a line, a ray, or a segment that divides into two equal, that's the key there, it's making two equal parts, a given segment or angle. So I can have a segment and I can come down and separate it into two equal parts, and that bisects it. We could also have an angle and have a ray come out of there that separates that angle into two equal parts, and we would call that an angle bisector. So there's a segment bisector and an angle bisector. We also have something called perpendicular bisectors, and it's really similar. It's going to divide the segment into two equal parts again, but this time it's going to also create right angles because it's perpendicular. And you can see that picture is over here. You can see that this segment right here was separated into two equal parts, and it's creating a right angle right there. And actually all four of those would end up being right angles in this case because they are vertical and linear pairs to each other. So all four of those would be 90-degree right angles that are being made by that perpendicular bisector. Like I said, that's going to be useful in just a few minutes. Let's go ahead and look at our first example though. Example 1 says, find the equation of a line parallel to 5x plus 2y equals 10 and goes through the point negative 2, 4. Well, the first thing we have to know is if we're looking for parallel, I need to have the parallel slope, right? But this equation is not written in a way that I can just pull the slope. It's not written to y equals mx plus b. It's not in slope-intercept form. So let's turn it into slope-intercept form. So I take that 5x plus 2y equals 10. And let's go ahead and turn that into its slope-intercept form. So the first thing I'm going to do is I'm going to subtract that 5x to the other side to get it, isolate that y. We want to get y by itself. Well, that's going to be nice because right here is going to cancel. My 2y comes down over here. Well, I can't actually combine 10 and negative 5x, so I'm just going to write it out as an equation. We always put our x first because that's mx, so there's my x. And then that positive 10 will go in the end as a plus 10. Well, I can see there's just one more step there then to get y by itself. We'll divide everything by 2. So if I divide this y by 2 to make this cancel right here, I'm going to also divide this by 2 and this by 2. What's happening is you're dividing that whole side by 2, but sometimes when we don't write it out in each piece, we forget to divide one of them. So just divide each piece by 2. So right here we'll cancel, and I have y equals negative 5 over 2. Well, I can't simplify that. I mean, we can make it 2.5 if we wanted to, or negative 2.5, but I'm just going to leave it as a fraction because that's how we do it when we write our slope-intercept form. So I have negative 5 halves x plus 10 divided by 2 is 5. So you can see our slope, rise over run, is 5 over 2. All we needed, though, is to know that the slope of a parallel line, well, the regular slope is negative 5 halves. We know that when we do parallel slope, well, the slope of a parallel line is the exact same. So we know we're also going to use 5 halves. And when we go to actually figure out what line we're going through, this is the point they gave us. So they gave me two things here. They told me an x and they told me a y. We know this is our x value and this is our y value. So I know that x in my new line is going to be negative 2. I know that y in my new line is going to be positive 4. So all I need to figure out is what b is. Once I know what b is, I can actually write an equation of y equals mx plus b. So I'm going to use this information here to help me do that. Y equals mx plus b. Let's plug in what we have. We know the y value is 4. We know that m is negative 5 halves, m parallel. We know that x is negative 2, and b is what we needed to find. Oh, this is an easy one. This is nice. This 2 right here and this 2, well, if you multiply 5 halves by 2, the 2's are going to cancel each other out. So all we have to acknowledge is the fact that this is a negative times a negative, and so a negative times a negative is going to give me a positive. So this is going to turn to positive 5 plus b. Subtract our 5 from both sides, and we get negative 1 equals b. So now I know b equals negative 1. that means I can write my equation y equals m. And remember, when we write our equation, I don't really care about x and y. Those were just used to help us find what we needed. The pieces we actually need are the b and the m. So I'm going to write my equation right here. Y equals, we're going to fill in m, negative 5 halves. We're going to put an x, y equals mx, and then plus b. Well, plus b is negative 1, so we'll just put a minus 1 right here. And that would be the equation of a line parallel to that standard form that goes to the point negative 2, 4. Well, the next one is the exact same question, but this time they said find the line perpendicular to this equation. So we're still going to take this 5x minus 9y equals 36. And we're still going to get that into its slope-intercept form so that I can find my slope. So I'm going to subtract 5x, subtract 5x. We still have a situation where we can't actually do anything other than cancel that out and then rewrite it as negative 5x plus 36. Just write it as a new equation. And then I'll go ahead and divide by negative 9. Remember to divide that to both things over here, the m and the b. And then I end up with y equals, well, negative divided by a negative is a positive, so the negatives cancel. 5 divided by 9 doesn't simplify, so I'm going to leave it as 5/9, put my x next to it. This simplifies though. 36 divided by 9 is, or negative 9 is going to give me negative 4, so I'll put a minus 4 right here. And this is super helpful because remember, this is my slope, but we want to figure out what the perpendicular slope is. So m perpendicular, well, that's going to be the opposite reciprocal of this. So since this is positive, my answer is going to be negative. And since this is 5/9, the reciprocal of 5/9 is 9/5. And again, up here, they gave me an x and they gave me a y. So my x equals negative 5. My y equals, oh, I forgot the negative. My y equals 5. We need to know what b equals to solve this problem. So we'll come over here and we'll plug in our stuff. Y equals mx plus b. Well, my y was 5. My m is negative 9/5. My x is negative 5, and we need b. Well, again, they gave us a nice situation here. The 5s are going to cancel each other out, and the negative times the negative makes a positive. So I get 5 equals 9 plus b. Subtract that 9 from both sides, and I get negative 4 equals b. Well, now that I know this equals negative 4, we have our two important pieces, this one and that one. So for my final solution, we're just going to use those two pieces. Y equals m, negative 9/5, x minus 4. So a nice trick, now that you've kind of seen how to do this and you see what's happening, notice that every single time I've solved these standard equations, I subtract the x and then divide by the number in front of y. Every time, subtract the x, divide by the number in front of y. And when I do that, I get the slope. Notice that we don't really care about this. This plus 5 here was irrelevant to the whole problem. This minus 4 here was irrelevant to the whole problem. So as a good shortcut that you might want to add to your little questions and reflections that you might want to look at is if an equation is in standard form, ax plus by equals c, well, the slope is really easy to find. It's just negative a, the opposite of a, over b. Make sure you keep whatever signs in front of b. Like right here, in front of b was a negative 9. So the opposite of a is negative 5 divided by negative 9, which would give us 5/9. The opposite here is negative 5 divided by positive 2, negative 5 over 2. So you can always get that answer just by changing the sign of the first one and dividing by whatever sign is in front of y. All right, remember we talked about bisectors up top. This is where that's going to come in useful. This question says find the equation of a line that is perpendicular, the perpendicular bisector of the points 1, 4, 1, 4, and 5, negative 2. Oh, I gotta find the perpendicular bisector. Well, remember we just talked about that. We said that the perpendicular bisector is gonna be the point where we could divide this into two equal parts and it would create 90-degree angle. Well, I need two things then. I need to figure out what the slope of this new line is gonna be, and I need to figure out what point it's going through. Let's start with the point it's going through. That's pretty easy. This point right here, we've learned this. We learned this a couple weeks ago. This point is directly in the middle, right? It's dividing this into two equal parts. So if that's in the middle, we know that's the midpoint. So my first step is to find the midpoint of A and B, or of these 2 points. To find the midpoint, remember you add them together and divide by 2. So I'm gonna add my x's. 1 plus 5 divided by 2, and 4 plus negative 2 divided by 2. So this is going to give me 6 divided by 2, which is 3. And this is going to be 4 minus 2 is 2. 2 divided by 2 is 1. So this point represents this point right here, the point that we're going through. My 3, 1 is the point we're going through. I also need to know the slope, though. The slope. Well, I can't figure out the slope of that line, the perpendicular line, until I find the slope of the original line. So I need to find the slope of the line that goes through the points 1, 4, and 5, negative 2. If you do not remember your slope formula, it is change in y over change in x, or y2 minus y1 over x2 minus x1. So let's go ahead and figure out what that is. I'm going to take my y2. So y2 is negative 2, y1 is 4. So I'm going to have negative 2 minus 4. x2 is 5 and x1 is 1, so 5 minus 1. Well, negative 2 minus 4 is going to give me negative 6. 5 minus 1 is going to give me 4. And I can divide both of those things by 2, so overall it looks like my slope is going to be negative 3 halves. Again, I just divided this by 2 and this by 2 to simplify that fraction. So negative 3 halves is the slope, and my midpoint is 3, 1. This is everything I need. This is the 2 things that we would have pulled from here and here up above. So, or here and here. So this is the slope, but I need to make it the perpendicular slope. So the perpendicular slope is what I'm looking for. So right here I'll write m perpendicular. So we're going to do the opposite of 3 halves, which is, it was negative, so it's going to be positive. And then the reciprocal of 3 halves is 2/3. Remember, if it was parallel, we would just leave it the same, but because it's perpendicular, we have to do the opposite reciprocal. We figure out what our x is. Well, in this case, x is 3. We figure out what our y is. In this case, it's 1. And we're looking for b. So we'll put that into y equals mx plus b. I end up with 1 equals 3. Oop, I did that backwards. Sorry. It would have been 2/3 first, but we can multiply in any order. So m and then x, I just switched them, plus b. Again, look how nice these problems were. We're going to make some canceling happen there. 3 times 2/3 is going to cause that 3 on the bottom to cancel, so I get 1 equals 2 plus b. Subtract 2 from both sides, and I get negative 1 equals b. And look at that. Now that I know that b equals negative 1, again, we just pull b and m out to make my perpendicular equation. So in this case, the final equation is going to be y equals positive 2/3 x, and then this is a minus 1, so we'll put minus 1 here, and that would be the perpendicular equation that bisects between those 2 points. As always, if you have any questions, please let us know. Hopefully that will help get you in the right track. Bye, everyone.